So today we're going to talk about how to build your own private GenAI chatbot using Java. And I'm going to cover the issue that Mala pointed out about protecting your data, because most companies don't want their data on the servers of like OpenAI or any other company. So what I'm going to do is I'm going to go step by step, as my subtitle says there, and I'm going to take a step back to go forward. So I'll make sure that everybody understands the basics, and then we'll talk about creating our own chatbot. So it's a fast ride. So hold on. So these are all topics I'm going to cover, and yes, I'll try to cover all that from a very high level in the next hour, hopefully with some demos too. So let's take a step back. And something that I talked about last year at my talk at DevNexus and also at the New York JavaSIG is that this gentleman in the 40s said this, that the world is considered to be made up of patterns. Now, he said this in the 1940s. He didn't say it yesterday. He didn't say that in an OpenAI conference. It was back in the 1940s. So my little riff off of that is that it's not only the world, but it's the universe is the patterns. Because with I have a pretty varied background. Not only am a Java developer, but software developer in general, C programming, scripting, Unix, all that stuff. But I'm also a musician, and I also went to school for astrophysics, and I also worked on Wall Street. So there was a common thread through all of this stuff. In music, there are patterns, right? There are chord patterns, there are melody patterns. In nature, like you see those bears, how do they catch their food? There's patterns, right? There's sports patterns, whether it's American football, where we typically don't use our feet. It's a penalty if you use your feet, or real football. There are patterns that the defense uses against the offense, but they're patterns. And in astrophysics, certainly there are many patterns. And like, okay, there's supernova, and like, how does a supernova compare to like Elvis Presley or Kurt Cobain or musical trends? When I was studying this stuff, I said, actually there is a correlation on how things went along, and then there was an explosion and something happened. So there are patterns all over the place, and we know about patterns in software. We went with the famous Goth, the Goth book, the Gang of Four book, and that was based upon a pattern language, which was a pattern, and that was based on a talk about pattern languages, and that was based upon building construction patterns, and which was based upon centuries of building buildings. So there are patterns all over, right? Patterns are everywhere. So what machine learning is, it's all about patterns. Okay, we look at patterns in a data set, and we either predict patterns like the weather, right, or predicting sports scores, if you're into that, or you generate things like what's trendy right now in generative AI. So machine learning is all about patterns. And if you look at the big picture, and this is reality. It's not like you go to watching. In the U.S., we have a TV show that supposedly is a news show, and they talk about AI, and they use it incorrectly. And sometimes you read like some websites, some layman websites, and they confuse the terms. But the big picture is artificial intelligence, basically, mimicking a human intelligence. You could argue whether that's intelligent or not, but for now, let's assume it's intelligence. Now, so expert systems, knowledge graphs, all this good stuff back, in the 50s, 60s, 70s, especially in the 80s, that was all popular. So machine learning is this subset in blue. So machine learning is all about pattern recognition. Okay, it's all about pattern recognition. Then there's a subset of machine learning, which is what we're doing now. It's called deep learning, where it's about patterns, but we're using extensive data structures like neural networks. We're using cloud computing, all the good stuff that we know and love, maybe not love so much, but that we know now. So that's called deep learning. So deep learning is a subset of machine learning, is a subset of AI. Now, within deep learning, there's two basic types. There's predictive AI, and this is the JSR that Zoran Schwartz and I have come up with, the Visrac JSR. It's predictive AI. It's classification, looking at something and seeing if it falls in a pattern. That's predictive AI. The predictive AI business has been around for like 10 to 15, maybe not 15 years, but 10 to 15 years. So predictive AI is used in advertising, like why you get certain ads, predicting the weather, or looking at an image for truck tires and say, is this a defective tire? Classification. That's been going on for like 10 plus years. That's predictive AI. That business is humongous. And we're talking about $100 billion easily. So that's that business. So, but lately, over the past, probably the last year, it's been really popular. It's something called generative AI, where we're not just predicting, but we're actually generating something. So right now, the business for generative AI is smaller, way smaller and predictive, but the growth certainly is projected to be as big as predictive probably within 5 years. So, but there are two types. They're equally important. It's incorrect, in my opinion, to say like generative is going to surpass predict. They're both used for two different use cases. We know as programmers, you use the right tool for the right job. So sometimes they're predictive, and sometimes they're generative. Like you're not going to use generative to do the weather unless you invented something that generated weather. So there's generative and predictive. So let's, again, take a step back. And I'm doing this for a reason, because when we talk about generating your own chatbot, you have to understand some of this stuff. So you see this picture zillions of times on the web. So a neural network is a data structure that was derived back in the 40s, right? Believe it or not, back in the 1940s. It's a data structure, and nowadays it's a collection of data structures where there's inputs, like the thing on the left is there's inputs, like some text you're inputting, and then there's the output on the right, something that you want. In the middle, there's this massive amount of connections and artificial neurons in the middle. And each one of these boxes has certain weights and like certain probabilities and weights. So what you want to do is you want to tweak all the parameters of all these boxes so that when you put certain input, you get the expected output. So this is way different than traditional IT. Like we're used to from decades of doing traditional IT, is that we want the machine to tell us the output. Like we have the input, we have data, and in the middle, we give the machine structure. We say, here's our algorithms, here's our data structures. We give that to the machine, and the machine gives us the output. This is different. So we have the input, the data, and we have the output. We know what we want from the output, and we're telling the machine, give us the middle. So this is different from traditional IT. Now, since this thing in the middle can be quite complicated and CPU intensive, and it's typically like a sparse matrix. So there's I hate to call it a shortcut, but there's a representation of the middle section, and that's called the embedding layer, where it maps this sparse matrix into a vector. Now, I mentioned that for a reason, because that comes up later on when we talk about embeddings and similarity. But so the embedding layer is a representation of the middle that maps this massive mesh of connectivity to a vector, in other words, an array. And in 2017, the world changed. So I've been doing ML for a while. I mean, oddly enough, like back when I was doing my graduate project, as I said, I'm a musician, so I want to do something fun for my graduate project. So I wanted to look at melodies of a composer, and I wanted to generate original melodies, but in the style of certain composers. So I had to figure out how to come up with patterns based upon a composer's style. So I built this probability tree, and then looked at node sequences and things like that. So that was many. You can tell from the color of my hair. That was many decades ago. Little did I realize I was doing generative AI back then. And the music industry has done this stuff for a long time. So this is not new. I mean, sometimes the computer world thinks that they're the first from everything. This has been done in the music world for a long time. But in the computer world, in 2017, Google invented this thing called a transformer architecture. Now, this changed the way that we looked at text, specifically language, natural language processing. So 1, 2, 3, 4. there's 8 people on this paper. They are no longer at Google. Not a victim to layoffs, but no longer at Google because they all have their own companies now. So this was a major invention/creation. So before 2017 was classical machine learning, and that's where Zorn and I were working on classical machine learning. But after 2017, the world changed. So, and this is where generative AI became quite popular. And Google has patented the transformer architecture. Little known fact. Why they do that, I'm not quite sure. I mean, why they haven't said anything about that. And sometimes companies they hoard their patents for later on whenever there's a legal case that may come up. So that there's interesting ways how big companies handle patents. But anyway, but what is a large language model? Okay, we know what a model is. A model represents something. A language model is a model that represents language. A large language model is something that uses a large chunk of data to use as a data set to generate the model. It's not really a search tool, right? And when you read these layman articles and some of the non-computer websites or some streaming show or some television thing, it's like it's wrong. so we're supposed to be the smart people on the planet, so we have to get this correct. So the language model is not really a search tool. Can it be used in an architecture for a search product or search application? Of course, it's software, right? But it's not really a search tool. It's a text pattern recognizer and then probabilistic completion tool. So remember that. That's what a language model is. It's not a search tool. People, when you see people say they're using it like they're using a Google search, it's not that by itself, right? You have to teach it to recognize patterns. So that little red star there, the way it works is that you ask it to complete some text. Like, I want you to complete this text based upon the patterns that you know, and I'll give you a starting point. So I'll prompt you. So that's where those words come from: prompt and completion. So, for example, you go to ChatGPT and instead of typing in what some of these layman TV shows and articles type right away, they type in a question. Ignore that. This is what it really is. Roses are red, violets are. Hopefully this translates to non-US the saying, but this is a very popular saying. Roses are red, violets are, and you hit character turn, and ChatGPT says blue, because it looked at all this data out there and it says, okay, well, what's the most likely thing to complete that prompt that Frank just put in? Well, it's blue. It said violets aren't. Could have said something else. Could have said violets are purple, but it said blue because that was the most probabilistic completion of the prompt. That's what an LLM is. And ChatGPT is the web app that sits on top of that talks to the LLM. So the prompts, what you put as a prompts, they steer the behavior of the LLM. So for people that have done prompt techniques, they understand this already. For people that don't, that's why I wanted to put this here. They steer the behavior of the LLM. You're not touching the neural network. This is really important. The prompts do not screw around with all the weights of the neural network, like I mentioned before. It makes it so much easier, right? And then most LLMs behave similarly. So what you put for your prompt increases the probability of getting what you want. That's the purpose of good prompts, right? So here's another example. So I type in this little sports thing. Hopefully your soccer or European football, real football. So we have Messi, who is a famous football soccer player. He lines up the free kick with his magical left foot. He shoots and then you hit the character turn. And ChatGPT says, well, what's the most probabilistic completion of that? And he finishes scores. Some nice little description of how Lionel Messi kicks the ball into the net. Okay, so it's a pattern completion. It's a text completion application. So if you learn that first as an LLM, then you understand what an LLM is. And if you learn it like you type in a question like what is Java, that's really don't think of it like that. Think of it like it's completing text. And of course, with all the language models, whether it's OpenAI or it's um, Gemini from Google or Anthropic or any other ones, there's many applications. I mean, Volkswagen has, for some unusual reasons, has access. They have a application that talks to OpenAI. I'm not quite sure what it does, but they have an application that does that. And of course, there's chatbots like ChatGPT, right? Now that's what I'm going to focus on. I'm going to talk about chatbots, and we know about REST APIs. That's how the web works. So, and before I talk about the Java API, just to show you real simple, it's like a little curl script. So in here, I'm talking to the endpoint for chat. And there's some headers you have to pass. You have to pass the API key, which is, you have to go to the OpenAI site to register an API key. It's, truly easy. But then you pass this like little language. All right, what model do you want to use? So OpenAI has many different models to use. There's GPT-4, the 3.5. There's some really, really cheap, I should say inexpensive models for you to use. And you send it this little language. Here I have messages. So there's a language that it understands, and you have to give it like, here's my prompt. Here's how I want you to respond. Here's additional information. So it's like a little language that you send to the server, right? And then you get back, because I asked for JSON, you get back this. Right, so you get back some data, some metadata about your response, but then in red, you have the content. I asked for a hello world in Java, and if you look at that red, there's a little Java program. So it gave me some code back, but that's what you get back, right? That's the response back from the rest. So how many models are available? So we've heard about GPT 3.5 and there's GPT 4. There's Gemini, there's blah blah blah. So how many models do you think are available? I'll give you five seconds to think about that. Take a guess. Okay, so as of February 12th, which is some weeks ago, there's 500,000 models. There's over 500,000 models to use. So there's not 2, there's not 3, there's not 5, there's not 10, there's not 12. There's 500,000 of them. And it seems like, I bet if you went to that link down the bottom, it's probably about 540,000 models. There's a lot. And they're for different purposes. Okay, so now let's talk about prompt techniques. Okay, so we know we've heard about prompt engineering. It's not really software engineering. You can argue that's not really engineering. They're just prompt techniques. Okay, now prompt engineering, and I'm using the term loosely, the techniques that might produce good results. It's not techniques that will produce good results. They might produce good results. And the better your prompt is, the better your result is. So there's all these techniques in prompt engineering, right? But the key word here is might produce good results. So check this out. So here's GPT 3.5. So I ask it, what is the 7th word in this phrase? I said, Frank Greco is a software developer who lives above. So the 7th word is who? And ChatGPT says, well, 7th word clearly is software. It's like, well, that's wrong, because most likely it's this people asking for the 7th word is not likely. You probably would ask for what's the first word? What's the last word? You're probably not asking for the 7th word. So it got confused. So I just basically took a guess, or took a probabilistic guess. And then here's GPT-4. That's just another model that OpenAI has. It's what's the 7th word in that phrase? And it says, oh, clearly it's developer. And so that's wrong too. So because if I had asked it, what is the first word? I would guess that would get it correct. If I said, what's the last word? It would probably get it correct, because those are most common things you're going to ask. But if I said, what's the 11th word, or what's the 16th word? It's probably going to get it wrong. Unless you train it better, it's going to get it wrong. So prompts are not always, won't always give you the correct answer. It's how you formulate the prompt. It's also, of course, the data. Of course, we always forget about the data, but the data is the most critical aspect of this. If you don't have the data correct, if it's not clean data, unbiased data, garbage in, garbage out, right? So here are some tips, and OpenAI has a lot of good tips on it. Be very, very specific, right? This is a bot, just like, watching some sci-fi movie. Be very specific, right? And give plenty of examples. And it doesn't really understand when you say, don't do this. So negation is fairly difficult for an LLM to do. It's better to tell it what to do. And there's a lot of research on negation in LLMs. This is still early days. This is early days for all of this stuff, right? I mean, it takes a long time to create useful stuff out of a new technology. So we're in the early days, right? And regrettably, sometimes we're going from R&D into production, which is scary, in my opinion. We're missing the middle part of testing, but so we're in the early days. So we're learning a lot. So there's a lot of techniques. I can't possibly go over all the techniques. That's just a few of them. There's probably a dozen, 2 dozen techniques. So here's some basic ones. So the zero shot is that I give it like explain generative AI. I didn't give it any examples. That's all I said. There's no examples. Just here, explain generative AI. That's an easy one. Few shot is that let me give you some examples first of what I want. And notice what an example is doing. An example is giving you adding more patterns for the LM to understand. So here I'm saying this is a fantastic product. Rate that a 10. No one responds to my emails. Sounds like me. Give it a 0, very negative. So you give it some examples, and then you say the last one, still waiting for a product of 6 weeks. What would that be? Well, you gave it some examples. So that's you complete it completes your prompt saying, no, well, that's probably a 2, negative. So that's called few shot because I'm giving it examples. And there's a lot of studies on few shots and different stylistic tweaks to few shot. But that's what few shot is. There's chain of thought where you say, like, here's my thought processes on how I solve a problem. And you give it, here's the question, here's a solution, and here's a new question. Now, based upon how I solved that problem, how would you solve the problem? So you're telling it, you're training, you're just giving it more data. So that's called chain of thought. Like, what is my chain of thought in solving this problem? And that's been proven to give a lot of solid answers. And this whole thing about prompt techniques, there's many others. There's a lot of research happening with this. This is all new stuff. People are tweaking, they're adding this, adding that. They're using LLMs, collaborative LLMs to do prompting back and forth. This is a new area. Just one of the topics that you have to really stay on top of on prompting techniques. And the way you structure a prompt is that you don't just give it a prompt. Okay, right? Just like I mentioned, you have to give it context. So you give it context, like you give it examples, right? How to behave, and then you give it your actual prompt, and then you say, like, well, give me the output. Maybe you want some JSON, or you want a table, or you want some sort of other output, maybe a different language. So a prompt is not just a thing that you send, right? There's also the context and how you want it. And some of these prompts can be quite long. And recently, you send this. I think it was Gemini, Google's Gemini, has increased the size of this prompt this whole so-called context window. I think it's like a million tokens. So it's big. Whether that's good or bad, I think it's a TBD, because now there's some studies. Again, this is still R&D level stuff. People have looked at, is a large context window useful? I mean, where do you put the data? Do you put the useful data at the beginning of that, or at the end of that, or in the middle? So now there's studies out. It depends where you put it in the context window. So this is all new stuff. So let me talk about OpenAI, since that's the big girl in the game. They have all kinds of services, some really, really cool services, and it's a lot of fun, actually. So I started playing around with this about a year ago, and I wanted to learn about all their APIs. So they have a set of REST APIs, of course, for us Java developers. There's very simple REST APIs. So when you with the rest of the base, I mean, go back to this for a second. There's the URL for the APIs. It's quite simple, right? And just to show you as a curl script, the language in the middle, this message is quote unquote language. Here I say like, okay, I want a joke about Java programmers. So that's, you have to give it what role, and a role can be three things. It can be the user, like you're sending, here's what I want. You can say, how do you want it to behave? That's called a system role. So you're telling the LLM, I want you to behave like this. So it's sort of like an out of band message. There's also a third message called assistant, which took me a while to figure out what that was, but it's kind of confusing. So there's user, system, and message. And so here I'm telling it to behave as a hilarious insult comic to get a funny joke about Java programmers. All right, so there's this user, there's system, there's user. There's also assistant, which seems kind of weird. It's like, wait a minute, I'm sending an assistant. Shouldn't I be receiving assistant messages? So when we build a chatbot, you'll understand what assistant means. So if you haven't been have not built a chatbot, you won't understand it. It'll be confusing because you think like assistant should be the thing coming back from the LLM, which it is, but it's a little more subtle than that. But I'll explain that. But if you want to play around with the REST API, I mean, you can do it like with a curl script, like I was doing. There's the REST. You have this little REST playground, like the usual type of REST tool, little web app that allows you to play around with all the parameters. There's on the right, there's all kinds of parameters that you can set. There's how long you want the result. There's something called temperature. So temperatures. Whoops, what just happened there? I just lost. That was odd. So temperature. So way back when I did my graduate project, so I was looking at melody, how melodies go in a certain style. So for example, if you had like a composer, let's say like you had like Eric Clapton. Eric Clapton picks the note G, and what's the next note in the melody? Well, it might be a B or it might be a D, right? If you know about music, it might be a third major third, it might be a fifth. But if he only, in the songs that you look at, if he only went to one way or the other way, there's 50-50 chance it went that way, 50-50 chance it went that way. So all the songs that you generate will either have one or the other. So there's no creativity, right? As I said, there are three roles for the OpenAI LLM. There's the user, there's the assistant, there's a system, how you want to behave, and then there's the assistant, which I'll explain a little bit as we get forward with chatbots. So let's talk about the API. Finally, we can talk about Java. So when I guess a year ago, when I started using ChatGPT, it was ChatGPT 3.0. So I said, well, okay, it's a REST API. How hard can it be? So I created a little bit of REST code in Java, pretty simple stuff, and it worked fine. And then they came out with 3.5, and everything broke. I mean, after all the work I did, and then 3.5 came along, and they changed the message format. They changed everything. They changed the end. It was like all my code just like broke. And so I said, oh, yeah, I could do this all over again. I said, you know what? I'm supposed to be a professional programmer, senior programmer. Let me see if someone else has done this, and I'll just use it. So I looked around, and even OpenAI suggested there's someone that Theo Canning. He has a really good set of wrappers around the REST API. So I said, thank you, Theo. So I got his code, and there's a link to it. He did a really good job, and it works fine with GPT-4 and all the new stuff that OpenAI came up with. So I would suggest that you go to that site and get Theo's code. It makes it quite simple. And here's an example. So and this is literally the entire. This is one page of code, right? This is less than a page of code. So you open up one OpenAI service. That's his API call, and there I have duration like timeout after 30 seconds. And here's a little bit of code. I want to use the so-called Babbage code, and that's like a really inexpensive LLM. So like when you're doing testing, you don't want to use GPT-4 since it's it's more expensive than the other ones. So Babbage 002 is really inexpensive. So there's my prompt. I said, give me 3 completions. So you can get more than 1 completion. I said, give me 3 of them. I don't want anything more than 10 tokens, which is about approximately 10 words. And 0.3 means, I don't want it that creative. Don't be too creative. Just like, if you want it deterministic, you would set that to 0. But I said, all right, give it 0.3. And then you get the output. That's literally all the code you need. And here's another example where I'm sending it system messages and user messages. So the system here, you're a funny comedian, and respond is one. Or you could say, I'm a helpful Java expert. Please respond and help me out with Java. And here's another example. And this one says, give me only one, GPT 3.5. Only give me 1 completion and only give me 30 tokens, or approximately 30 words back. So that's another simple. That's literally all the code you need, right? So with that, you can follow. He has many examples in his repo. So he did a really, really good job. And thankfully, I don't have to redo my REST code. So finally, we get to chatbots. So if you're not doing a chatbot, you just call the REST APIs, right? So the OpenAI services, like most of the other LLM services, they are stateless REST calls, right? They're stateless REST calls. But if you're having a conversation with somebody, like a chatbot, you want state, right? Because you might say, like, what did Frank refer to before? That's state, right? But the REST calls are stateless. So what do you have to do? You have to introduce state. So when you build a chatbot, you keep a history of the conversation. You keep a history of the conversation, and that history collects over time, gets bigger and bigger and bigger, and you keep on sending it to the LLM as state. So over time, you're saying more and more messages, along with the prompts that you asked and the responses that you get back, the assistant messages. So you send back, here's what the assistant said, and that's how you label the assistant. Here's my message, and then you ask a new prompt. So the actual prompt that's actually sent to the LLM gets bigger and bigger and bigger. You got to be careful you don't go past your context window. So chatbot still uses the stateless REST calls, but you have to send a context along the way. Okay, so that's what a chatbot is. But how do I get the chatbot to understand our private docs? Because you don't want to send your private docs. What company wants to send their private docs to OpenAI? I mean, do you trust a company like OpenAI? I mean, I certainly don't. The whole company was going to quit on a drop of a dime because they didn't like the way the company was run. I'm not sure I trust companies like that. You always, like any IT manager, you always have to be protective, to be on a defense. So how do you protect against this? Well, there's a couple ways. Okay, so the way that you get an LLM to give you what you want, use prompt techniques like I talk about. Okay, this is so-called no code, like, okay, as if that's going to solve everything, but there's many techniques. It doesn't require IT expertise. Okay, but it doesn't use your information. It doesn't use your private code. Private docs. So there's a technique called RAG, Retrieval Augmented Generation, and it's been popular over the past, probably 6 months. It reduces hallucinations, like when we asked it for the seventh word in that sentence, right? It was hallucinating. Right? Hallucination is probably a bad term. It's delusional is probably more accurate. So it reduces hallucinations, and you don't have to send right. It does require data storage, but most companies understand, databases, things like that. Okay. Then the other ones down here, there are other ways to make an LLM give what you want. There's something called fine tuning, but you have to be really a data scientist, understand statistics and data. You have to be a data engineer. It'll give you very specialized information, very accurate, but you have to know what you're doing. You have to be a data scientist. Not everybody in the world is going to be a data scientist. I know many of my students will never ever be data scientists. You're just not that type. So some people are front-end developers, some people are back-end developers. Then usually, rarely do you get somebody that's good at both. The same with this stuff. You have to be a data scientist. You can train your own model if you have a lot of money. You create your own foundational model, and not too many people are going to do that. It's expensive. And you can write your own LLM, which of course only a handful of people on the planet can do that. So the thing in green, so prompt techniques, we know we can work with that in RAG. So this is a cool thing called RAG, right? So RAG solves these problems. So the foundation model typically doesn't know about my docs. It still hallucinates, right? Delusional, or what's the term that confabulations. It's not sure which one's more accurate, but it basically gives you the wrong answer, right? The foundation model is not always updated, right? If you had your own data, you would keep it up to date because that's your responsibility, right? And you don't know where the data came from. What doc did that information come from? What PDF did that come from? What URL did that come from? You have no idea, right? So prompt engineering okay, but it's there are a lot of issues. So what RAG does, and it was this paper in 2020, and actually this paper was based upon another paper from years before on conversation context, on how having a conversation with a bot, like you have to provide a context. Well, so like all papers that you stand on the shoulders of other people that came before you. This paper, which came from Facebook, probably one of the more useful things that came from Facebook, but I digress. In retrieval augmented generation, you're retrieving information and you're augmenting the context that you send to the LLM and then generating the answer. So this is 2020, so it's recent. So this is the context part, right? This is the context part where you have to put in context from your private docs. So this is the overall RAG architecture. So you have the prompt from the user, and then you say, well, I need to get context. So I need to go to a data store, right? I need to go to a data store, and I mean storage, not a data store, the data storage. And you look for things that are similar to the prompt, and you get that data, and that's the similar data, and you add that to the original prompt, and you send that to the LLM. So that's the context. So this is really high level of basic RAG architecture, and then you get the completion. And then how you get stuff into the vector store, whether it's text or URLs or PDFs or MP3, transcriptions, whatever it is, you have to figure out how you want to chunk it, and I'll talk about chunking strategy. Chunking just means, do I want sentences? Do I want to use the number of characters, like you only use 512 characters? Or do you want to use markup? I want to use HTML. I want to use Markdown. So, and chunking strategy is just like prompting. These are all new. So things are moving, right? So just have to follow these things. When you build a real production application, you have to keep these things are moving targets, right? And you have to monitor these things. So the benefits is that you get content that's up to date, right? And it's specific to the question, or actually the question specific to the prompt, right? And you reduce the hallucinations. You don't eliminate them, but the techniques, use prompt techniques plus RAG to bring the hallucinations lower and lower. Of course, you have to always monitor this. So then you might have to tweak your prompt or tweak how you get data, right? And you're in control of the data. You don't send the data to your LLM. You're not sending the data to your LLM, right? You have the data at data store. And then what's really cool is you can save the citations in the database. So not only do you have some things that are similar, but you can say, well, what URL did this come from? What PDF or what Word doc they came from, or what Google Doc? So you can keep citations as metadata in the VDB, right? So, but then how do I find similar things? So let's talk about the middle part real quickly so I can show you some demos. So the RAG system has to find stuff that's similar, right? That's a keyword, similar. How do I find things that are similar? And that's my context. So how do I find something similar? So let's really quickly, since we're getting close to running out of time here, but let's say I want to find out how similar are these songs. So I have a bunch of songs here. There's from jazz songs to pop songs to rock songs. So how similar? Well, how can I How can I find out what's similar? Well, one easy thing is that I can look at the beats per minute. Some are fast songs, some are slow songs. So look at beats per minute. So here I put the beats per minute underneath each song. And so I can say, I can tell which ones are closer to one another by looking at their beats per minute. I can do a subtraction to find out if they're close or not. If it's zero, then they're really, really close, right? So it's helpful, but if you look at to the left, I mean, I have Summertime and Ella Fitzgerald, the jazz next to Green Day. Those two songs are not even close to being similar. But from BPM, from one dimension, they are similar, right? So I need to add more dimensions. So let's add more dimensions. I add what genre, whether it's pop, rock, jazz, and the x axis, whether it's slow or it's upbeat. So I kind of put them now during quadrants. So that's better. So I can see the difference from the x and y axis. It's better, but I still have things like I have like Taylor Swift next to Queen, or Metallica next to Taylor Swift. So well, this is also helpful. It's not quite the thing that I need, but that's only two dimensions. So that's two or three dimensions. Now, I can draw it in 2 dimensions or in 3 dimensions if I'm lucky. But since we're not, alien beings from the future or from another galaxy, we can visualize things that are beyond 3 dimensions. It could be hundreds of dimensions. Like for music, it could be major key, minor key. Is there a transposition? What do the lyrics say? Is it a sad song? Is it a happy song? Is there a bass? Is there a guitar? There's hundreds and hundreds of dimensions, right? And there's all these different mechanisms how you determine the value of dimensions. Now, OpenAI has worked with some researchers and some other work that, okay, I can come up with attributes of text, and here's what's called an embedding vector. So I typed in "hello world" to the embedding service, and it gave me, here's a vector, and it's 1,536 elements to this vector. This describes the string "hello world." This describes the string "hello world." I can give it any string, and if I have time, I'll show you a demo, and it'll give you back this vector with different numbers. So it's an array, it's one-dimensional array of floating point numbers, and it describes that string, right? And here's using Theo's API. This literally, it's a half page of code to get an embedding. Actually, I think I used this to get the page before this. So I get all that. And there's a little wrapper that to make it easy, because I'm going to use this wrapper a little bit later on. Get embedding vec is just that you give it the handle to the connection, and then here's the string, and give me back the embedding vector. Okay, so now I have embedding vector. So now I have two embedding vectors. How do I find out if they're similar or not, right? So this is easy. So you just have to do some matrix calculations. And if you remember back in university or even in high school, you're doing matrix calculations to figure out cosine. You're like, why am I learning this? Why am I learning this? Well, this is why you're supposed to learn. I wish I was just it wasn't about generative AI, but there are reasons why mathematics exists, right? So this gives you the similarity of two vectors. This is one of the ways you could do it. And you might say, like, well, this is a little difficult. It's not difficult. I wrote the code that does that. So here's three methods that does what this page does. Okay, it's not hard. So you can use this code, and here I used my code, and I used Theo's code to get embedding. I got two embeddings. The first one up here, the second one. I said, like, how similar are they? And if it gives me a similarity that's close to zero, I'm sorry, close to 1, then they're similar. If it's giving me something 0, then they're not as similar. So that's how you figure out similarity. And then you can look at their database, what are similar, and then I'm going to use that as context. And you might say, like, well, I don't need a vector database. I can do this myself. Yeah, you can, but vector databases are it's a little more tricky, right? You need to provide CRUD functionality. You have to make sure that there's admin tools, there's security, there's data consistency. It's not easy. It's non-trivial. So you just use a database, and there's many databases where you store the string and you store the embedding vector, and vector databases are really good for storing long arrays of numbers. right? And then you can store URLs. Where did that data came from? What PDF doc did that come from? What Google doc did it come from? What MP3 did that come from, right? So that's what you use a vector database. There's plenty of them. I'm just probably only 1/3 of what there are. I happen to use Milvus because I was looking at all the Java APIs for all these, and they all have Python APIs. I thought Milvus had the best Java APIs, not a great Java API, but it had the best Java API from what I looked at. They all seem to be Python programmers that generate Java, so it's like, okay, but it was workable. So and you have to figure out what a chunking strategy is. But let's say I picked sentences. I mean, there's some pluses and minuses using sentences, but sentences was a good thing. So my chunk was a sentence. So everything, all my text, web, PDF, I broke everything into sentences, right? So because you need a chunking strategy, right? And here's all possibilities, and some of them are good for really granular queries. Some of them where you want some more detail, you might want a whole document. But I use sentences, and so the first thing is that I needed something to break a string into sentence. So I wrote this code. Give me a string, and I'll break it into a list of sentences, or basically a list of strings. So with that as my foundation, okay, so I can change the string into sentences, and I can store them in the vector database, which is pretty straightforward. Then I can find similar strings based upon the similarity, the cosine similarity that all vector databases have. So if I have that, what else can I do? Well, everything. So as Java programmers, we've been doing this for decades, right? We've been looking at all these docs and then parsing this stuff. We've been doing it for decades, right? So here's to read a text file into a string. I mean, that's a one-liner, right? CSV files. You go to the Apache Commons. There's another Apache reading PDFs, websites, Google Workspace. We've been doing this for decades. So we can now read in all these docs, convert them into a chunk, and I happen to be using sentences, and then store them in a vector database along with their source, whether it's here's the URL, or here's the PDF, here's the path name, whatever it is. So now let's see if I can show you some demos. I'm running out of time. All right, let me run this guy. What this is doing is just, okay. You're extremely funny comedian, or respond as a funny comedian. Okay. How should I learn Java? So this is a system message telling you telling it how to behave, and this is the question: how should I learn Java? And okay, but it's okay. Here is okay. So there's a response back. So it tries to be a little humorous. But, okay, well, that's not that funny. I said extremely funny. It's not so funny, but anyway. So that's using Theo's API, and here it shows you how easy it is to use. Right there's the model. My messages where I have a system message, I have a user message, put them in this list, and then send the whole thing to OpenAI. So that's that one. Here's an embeddings. Actually, sorry, make this a little larger. There's a embedding. So let me run this. And what is this doing? So I just have I ask the user for a string to embed, and then I'll show you what the embedding looks like. So get the embedding. All right. So hello world from Frank Greco. Frank. So it goes to OpenAI using back this vector. So there's 1,536 floating point numbers in here. So that represents, wow, where's my original? Here we go. So all the attributes of that string are embedded in this vector, 1,536. And I could make it another one. Oh, wow. And there's another vector. If I can find, sorry for making everybody dizzy here. All right. There's that string. So there's 1,536 elements in that vector, a one-dimensional array that represent that string. And then we want to find out how similar that one. Okay, so here's another quick example. And this guy. So I got the embedding for, I say, that string, and I got the embedding for that string, and I see, well, how close are they? And I used my code that I wrote, those three little Java methods, and it says 0.8. So the closer it is to 1, it's the cosine similarity is closer to 1 if they're close. So let me put something completely different there. It is raining today, unfortunately. And let me run this again. And if you notice, the number is lower because they're not so similar. So it says so you can use this number and you can say only give the things that are similar to it. So you can say, like, if it's within a certain delta, give me what's similar. And then you when you find out what is similar, you pull out the text that's similar and you put that together with the user prompt and you send that to the LLM. So I built, I didn't quite get to implementing Google Docs or Google Workspace, uh, formerly known as G Suite. I mean, Google tends to change the name of their things on a whim, or Word or Microsoft Docs too. That's the next thing I'm going to do. But I have, oops. Oh, yeah. So what I'm doing here is that this is a little command pattern thing that you learn when you first learn Java and interfaces. I think I pulled code out of something that was like more than 10 years old. 10 years old. But so I have some commands here. Should make this a little bigger. And so let's say, so what do I have here? Let me use the Java 22. So what I did is that I loaded in, since loading in URLs is pretty straightforward to do, I loaded in this website, InfoWorld, on Java 22, right? And I loaded in, this one, which was also Java 22. So I loaded in two URLs into this. It's sort of like a table in a relational database, but not quite. It's called a collection, but it's not like a Java collection, but it's like a table. And I'll say, let's say instruction. Say you are a helpful Java expert, right? So tell the LLM how to behave. Okay, what is in Java 22? Okay, so it gave me back. So actually, one thing, notice how it was a little bit slow. So, and you notice that ChatGPT gives you answers back right away. There's a parameter to the REST API that, do you want to bring back the entire result in one shot, or do you want to give it back in pieces? Like if you're a web program, you know what SSE is, server sent events. So you're asking the web infrastructure on OpenAI, so give me it as SSE, and I'll take it in as it comes. So it's more like a chat, how humans behave, right? It's like a chat, but that's using SSE. So you have to add code to your Java program to handle SSE. You have to use a thread. It's a little more complicated than just what I did, but this is very straightforward. So get the whole output, send it to me when you're done. So that's why it took a little bit more time. So it says about it's Java 22, and I can say, let's see, streams. Okay, so show me Java code to illustrate. Hopefully this works. Stream, I think they're called aggregators. Aggregators. Did I get that right? Okay, so again, it waited for the entire result, so it gave me some code back. So it's like when I finished this was so much fun to build, and I added a whole bunch of what's it commands about loading. I loaded URLs. I loaded text. You want to just load a note into the database. So I just brought this whole thing. This was so much fun to do. I actually, using some help from Ken Cousin, I was able to take an MP3, transcribe it, and then chunk it into sentences. And then I was able to ask questions on an MP3. That might take a little time to demo here since I am 3 minutes over, but it was very straightforward to do. So with that, I'll end here since I am over time. And if you have any questions.
Hi, Frank. That was an amazing session, I would say. I haven't worked a lot with LLMs, but I, it was amazing. I learned a bunch of things.
Good.
Also, kind of not thinking in a certain way, as you mentioned in your talk a lot of times, that a lot of people think about LLMs or prompt engineering in a particular way. So those were all good topics about the vector databases, vectors, how so many. 31536, what was the word that was used to store just the string hello world? So that kind of blew my mind. So that was amazing. I'm sorry because we are over time. We won't be able to take any questions. But when you asked how many models are there, so I think the top people went were 1,200. So that was the disparity that we were looking at.
Yeah, it's hard to believe
And
there are that many.
yes, yes, absolutely. And most people were agreeing to what you were saying. So one of the comments mentioned that, yes, what you told about, mentioned about prompt engineering, yes, that was correct. And it was more about people discussing, yes, that is right. So, um, yes, not really. Questions. Yes, one question. The code that you showed. Do you have a link to the repo, and are you okay to share that publicly? If yes, you could share that link with me, and we'll add it to the description of your demo. Or if you would like to tweet that yourself, we're
Yeah,
good.
I could send you. I have to do a little bit more work over the next few days, but I'll send you the link when I'm done with that. I wanted to add some additional things just to make it easier for people to understand.
Okay, okay, that would be great. And with that note, thank you so much
My
once
pleasure.
again. Oh, it was a pleasure to learn from you, Frank. That was an amazing session. Thank you so much for your time. Really
Thank you.
appreciate that.